This is the Java OCA Unit 2 Lecture 2 on Java primitive variables. In this presentation, we will discuss type safety, primitive types, and identifiers. The Java programming language is called a strongly typed language. And this programming language requires that variables have a declared type. This is known as type safety, and it provides the following benefits. It prevents type errors during compile time. It prevents type errors during runtime. It ensures that variables can only access authorized memory locations. And it makes for an efficient debugging of programs and reduced memory leaks. Now, benefit number 3 ensures that variables can only access authorized memory locations. This also has to do with using the approved methods that go with a variable or a class and not having access to methods that belong to other classes. If you look at the image on the right here, it says, notice that the use of double quotes, which is reserved for strings and not char data, causes a type mismatch. And we see that down below in the compiler feedback, incompatible types. When naming Java identifiers, we have what's called the recommended way to set variable names. But with the Java OCA course, we need to be aware of the non-conventional ways that variables could be named. And we're going to see here that things such as leading a variable name with an underscore are legal. We could also have a variable start with a $sign. Down here, the next one, I have the variable starting with a pound symbol or a cent symbol. So we have all of these currency symbols which it can start with, and all of these are legal. So when we look at this, it says identifiers are the names of packages, classes, interfaces, methods, and variables. Those are all the things we can name in our program, and they have the following properties where there's unlimited length. They can start with an underscore, a currency symbol, or a letter, whether it's uppercase or lowercase. You can use digits, just not as the first character. And the currency symbols and underscores can be at any position. So we normally don't choose to use these symbols when naming our variables, but these are legally named variables, and often these variables are named this way by the Java system or the JVM, and that the system might name variables in this way. So we should know that they are legal variables and they will not throw a compile time or a runtime error. And you can see the output down below here. You need to know all of the Java primitive types. We have char, byte, short, int, long, float, double, and boolean. And over here in the graphic, I have run some code in BlueJ to show you the max and min values of all of these numeric types, and the printout is down below. So the minimum value for byte is -128, the max value is 127, and we can go through all of the types here and see all of the max and min values. So we have 4 different integer types in Java. There's byte, short, int, and long. We use int the most. But these are some of their characteristics. We see the range of values for byte. It uses 1 byte of memory. Short has values from -32,768 to +32,767. It uses 2 bytes of memory. Then we have the range of values for int. An int primitive data type uses 4 bytes of memory. And then we have the range of values for long, and a long variable uses 8 bytes of memory. So next we have the Boolean type. A Boolean variable can store true or false. The default value for Boolean types is false. A Boolean variable called bool can be toggled using this expression. So we have bool is equal to not bool. That means if bool was storing false, when it is equal to not bool, it would then store true. So this is known as a toggle method. Boolean values are essential to the control structures and decision-making in any programming language. And a Boolean type uses 1 bit of memory, and just to compare that to the other types, it takes 8 bits to equal 1 byte. Over here on the right, we have a graphic. The AND graphic shows that it belongs to both A and B. It is the overlap between the data sets. And the OR graphic is the union of both A and B, so it combines the two sets. This is the overlap, and this is combined. Next, we have the char type. Two types of data can be assigned to a char variable, either an unsigned integer, that means no negatives, or a keyboard character wrapped in single quotes. Again, char uses 2 bytes of memory, and its numeric range is from 0 to 65,535. And there's a little caution here that the OCA book tells us about. It says, casting a negative integer as a character assigns unpredictable values. So you can see up in the graphic, I have char C1 equals 100, and then the system out prints C1 equals 100, stores the following character, and we see the output for that is here. It gives us the character D. And then we have char C2, and we're casting negative 100 as a char type, and we have char C2 is going to give us, we have a character from another language, and there's no way to predict how it's going to take a negative number and turn it into a positive integer, because the positive integer 100 we saw was D and not this character. So next is our float type. Variables declared as a float store decimals with precision to 6 or 7 decimal places. That is what I found in multiple sources. It's not just 6 or 7, it's either or. The decimal must have a suffix attached to it, so it must end with a lowercase or capital F. The decimal can be stored using scientific notation, and just like the F could be lowercase or capital, the E could be lowercase or capital, and you should have been familiar with E notation with calculators. They use that representing an exponential base of 10. So this 1.3e negative 3 is the same as 1.23 times 10 to the negative 3 power. And it uses 4 bytes of memory, and we can see that there's some code here in the graphic. I took F1 was a float, F2 was a float. Notice F3 was the division of 2 floats. And then we printed out the results for each of these, and we see here's the output for F1, F2, and for F3. Then I have F4 is from the math.py class, but the math class pi value is a double. I casted it as a float, and then I printed the math pi as a double, so you have those 2 outputs, and you can see the difference. And we have the difference in precision, where the float goes to 1, 2, 3, 4, 5, 6, 7 decimal places, and the double goes to 15 decimal places. Double type variables are declared and stored as decimals with precision to 15 decimal places. The decimal can be stored with no suffix, but you could use a suffix if you'd like. You could add a capital or lowercase d to the end, just like you do with the floats, but it's not required. The decimal can be stored using scientific notation as well, and this uses 8 bytes of memory. Over here in the right graphic, I'm giving you a example with caution. It says, notice that line 8, so if we find line 8 over here and we follow it through, we have a variable that starts with a currency symbol and has an underscore. That's okay, that is a legally defined variable. It's dividing integers 6 and 4. Because it's doing integer division, 6 divided by 4 is 1, and then the equal sign is a right to left operator. And when we take that 1 from the integers, it will turn it into a 1.0 as a double. It's not going to give us the result 1.5. It's going to give us the result 1.0 because first it does everything on the right-hand side, which was integer division, then it stores it to the variable on the left. The equal sign is a right to left operator. And then we have just some printouts here using the various ways for naming variables with underscores and dollar signs. And we're trying to get you used to this because you will see plenty of notation like that on the OCA exam. So that is the end of this presentation. The thing you should focus on is the weird ways that variables could be named in the Java OCA exam. You also want to make sure you consider data types, and you want to make sure that you are looking at things casted or declared properly. These are the types of questions you will find in the practice for this unit.